Today, I'll show you the most beautiful equation in calculus. But first, let's meet a very special number. It's called E, or Euler's number. E equals approximately 2.71828. It goes on forever, just like pi. Now, when we raise e to the power of x, we get the function e to the x. Let's see what this function looks like on a graph. This is the famous exponential curve. It starts slow, then shoots up really fast. Now, what's a derivative? The derivative tells us how steep the curve is at any point. Think of it like this. If you're walking up a hill, the steeper the hill, the bigger the slope. We draw a line that just touches the curve. This line shows us the slope at that point. Now here's the magic of e to the x. At this point, the height is about 2.72. And guess what? The slope is also 2.72. The slope equals the height. And this works at every point on the curve. Let me show you. This means the derivative of e to the x is e to the x itself. Now, what about the integral? The integral measures the area under the curve. Imagine filling in the space between the curve and the x-axis with paint. But here's the key insight. Integration is the reverse of differentiation. We showed that the derivative of e to the x equals e to the x. So going in reverse, the integral of e to the x must also be e to the x. We add plus c because constants disappear when we differentiate. So e to the x is its own derivative and its own integral. It's the only shape of function that does this. Remember this beautiful result. Mathematics is beautiful. Fun fact, if you invest $1 at 100% interest, compounded continuously, after 1 year you'd have exactly E dollars, about $2.72. To master the math behind calculus, you need a rock-solid foundation. Download the 4K library and start seeing the math. Link in bio.